All right, so I guess some explanation for some people in this room might be in order. Just about all x86-based hardware these days uses what's called high-definition audio. Now, someone you may be able to explain it better than I can, but basically it's a specification that Intel put together back in 2004 to allow computer hardware manufacturers to be somewhat flexible with how they set up their audio hardware for their notebooks and desktops. The problems that generally the Linux audio community has is actually it tends to be more with notebooks than desktops. Generally, what has to be done for notebooks is, or for HDA hardware, is that there are different codec chips. There's Realtek, there's analog devices, there's IDT, I think, is there?
IDT is the new owner of the one that starts with an S. I can't remember it offhand, but yes.
Okay.
Sigmatel.
Right, Sigmatel, yeah. And I think they're the three big ones. There may be more.
There's another one. Connexat is another
That's
one.
That's right. Connexat.
They make the modem chips as well.
Right.
So.
So basically, you've got the codec chips, and then you can have different pinouts. Correct me if I'm wrong. Basically, you can assign different pins to different functions depending on what you're wanting to do, and how you've got your hardware, your motherboard set up, and everything. You have different lot of pins for output, input, both analog and digital, internal microphone, etc. And the problem we often have for new hardware is we've got to work out, because of course the hardware manufacturers, if they were nice, they could actually set this all up correctly in the BIOS, and the HDA driver and the kernel could probe the BIOS and say, okay, that's what we need to use. But often, if they do set it up in the BIOS, they do it incorrectly, or more often than not, I don't think they do it at all in the BIOS. So we've actually got to add manual quirks to the kernel HDA driver for those pinouts. So I guess that's what this session's about. How can we, given that we've got a kernel that's going to be set pretty early in terms of version, we need to work out a strategy to try and get as many new hardware quirks into the Ubuntu Lucid kernel, and then get them tested and make sure things work, and basically make sure we've got it, support as much hardware as we can without risking stability.
The biggest problem we have is by the time we get to release, the kernel we're using is 6 months behind and also development.
Yeah.
So we need to be more on top of ALSA and have it as a separated package if we want to have the more hardware support, because in between kernel releases, there could be 20 to 30 new platforms that are added just in the HDA area alone.
Yeah. But don't forget, I guess this is the real issue, though. Sometime, or it can happen, I remember it happened for Hardy. There's often, if we just use a new set of kernel-level drivers, it'll often break the ABI between user space and kernel space. So, for example, what we had for Hardy is we actually had ALSA lib, ALSA utils, ALSA tools, 1015. And in the kernel we had 1016. And it broke things in weird and wonderful ways, especially for people who wanted to use pulse audio. And since pulse audio has pushed ALSA in ways that's never been pushed before, it broke things weirdly. So Daniel and I have tended to just keep all the version numbers in sync to be sure that things will work.
Well, so that implies to the general ABI, but does it also apply to the forward of these quirks? Or are these more portable more easily than the entire driver?
Well, the also libs and also drivers are fairly closely tied together.
But things like the quirks are pretty small change.
Hardware specific.
Well, the quirks and stuff, with HDA audio, pretty much every platform out there is in a lookup table in HDA audio.
Right, but does it change so often, the forward of that? Or?
If one manufacturer, for example Intel, when they release a single desktop motherboard style with a single chipset, they may release 10 or 20 different versions of that motherboard. It'll have the same exact audio chip on it, but it'll have a separate quirk for each one of those motherboards.
Right. I mean, of course, the quirks change very often, but does their format change so often? So is it easily can they backport it easily to all the kernels?
Some can.
Some can.
A lot can't. Mainly because they pull in so much other code that's, infrastructure changes.
So is a quirk like this, is it just data? Like it's a mapping?
It's a lookup table, exactly.
So
but it's built into the kernel software.
Why can't we separate those out and deliver them out of process effectively?
That was actually a discussion that I brought up about 3 years ago with ALSA. The biggest problem is there's just not enough manpower in ALSA.
I believe the device tree will eventually possibly solve that, but that's down the track.
So is it out of scope for this conversation for us to look at essentially having a framework outside of the kernel where we crowdsource kernel module arguments, the quirks inside the various ALSA drivers, pulse audio settings, and so on, so that if somebody fixes audio on their laptop, they can effectively submit that collection of settings, and then somebody else can say, look, fix the audio on my laptop, and they can receive that collection of settings. Is that feasible? I mean,
pulse audio is much more feasible because it's user space, and generally, if things are set correctly at the kernel level, the driver level, pulse audio will just work.
So we had a mechanism before with Linux Ubuntu modules where we had the ability to wholesale grab later versions of ALSA outside of the kernel, but that went away.
That's going to cause problems with ABI sync. I'm just talking about the quirks, right? It seems that you will get a lot more platforms after release.
As long as the codec support is in the driver, you shouldn't have a problem adding new quirks to it. But it's when they add new sound codec chips themselves that you start running into issues.
Right, so that's new hardware effectively. What this has been described to me as often is just a question of mappings, pinout mappings basically, which device is connected to the microphone, which channel effectively.
And that's something that's fairly uncontroversial with the backport. I mean, there's no ABI change in adding quirks.
Right, it seems crazy to me that we have to do a kernel update for that.
The idea was that users themselves can follow a recipe to create it in the XML or whatever file.
But I think there's an effort in Pulse, from Lance talk at Plumbers, about getting a database of the sort of these changes.
It would be nice to rip out the quirks table from the kernel entirely and put it into user space, and then when you probe the module, you can take out the right cert and edit what you parameters.
Make it like a UDEV type thing, whatever. Yeah.
Because it would be so much easier also for users to provide new quirks.
But again, that's been talked about in ALSA development for the last 4 years.
But is it hold up a technical one or a resource one?
It's mainly a resource one, because when I was doing ALSA development a couple of years ago, I was overwhelmed just trying to keep up with the number of systems coming out on a monthly basis, just adding support for them.
So having this single common place would be easy.
Can you come and sit in, so when you go close up to the microphone, you're talking a lot.
and as I said, I think like desktops, I know for example, my desktop at home, the desktops generally they satisfy particular quirk profiles like 2 in 4 out, 4 out 2 in digital I/O, like 3, it's called like something like 4 stack dig or something, is the profile. It's all the notebooks. That's the real icky stuff in the netbooks. So
is it effort right now to build small to basically unify the naming scheme amongst the mixers so that Pulse Audio can pick them up?
I think because Pulse looks at that, it's become more important for these things are right.
Okay.
There's a problem whenever you change the name of one of the mixer elements and then you do the kernel tape, because you have your asm.state file, and that's going to end up having all the wrong names for it, and you just end up completely losing the state on what your mixer was. So if you don't mind having people's systems suddenly be muted or full volume on random mixer elements when they do this upgrade, then okay, but
so it seems like we should take a systemic view of this, right? I mean, it strikes me that this is a set of subsystems of people who don't talk to each other. It looks to the outside like a set of subsystems of people who don't talk to each other. You've got kernel folks, you've got ALSA folks, you've got pulse audio folks, you've got applications folks, and we need to sort of provide a whole system view of that and a mechanism for for people to say, this is how to fix audio on this machine, and then have that instantly available automatically to people who would benefit from that.
It sounds a lot like the old plugins that we had until a year ago. So until this was severely cleaned up. So like we had 4 or 5 different layers of key management, and now it's basically one.
And did we have to clean that up? Was that something that we had to do, or did that come from kernel and various other communities?
Well, we helped in it, and I did a big chunk of it. And yeah, first step was actually to sit down and see how all this stuff works. And this ended up being a giant diagram of how information and works and tables flow. And I think maybe something similar needs to be done for ALSA, like debugging ALSA quirks, like recipe and steps that you can follow, and then so that users, like technically inclined users, can contribute to them.
So right now, when we apply Quark, it necessitates a new version of the kernel, right?
Yeah.
Because the codecs and everything is part of the kernel. And again, I go back to that, we used to have the capability of applying these quirks separately.
We could do that if we didn't go with the latest ALSA modules. We kept the ALSA module at the same level as what's in the kernel, and we just applied the patches to the ALSA module package and make that a separate package. You can rebuild that against the kernel that's currently installed and not have to worry about ABI changes. But it's when you change the ALSA module version that you have to change ALSA libs and everything else that goes with that.
And the easiest way to get a whole new bunch of quirks is to take the latest version of ALSA. So there's usually a lot of pressure to get that.
Now, but if we did that, right, we still could grab the latest ALSA library. Like we tried during this past cycle.
You don't want version mismatch.
Right, yeah.
Well, I see what you're saying. If we grab...
You don't want to be changing both the kernel and the libraries and not changing Pulse at the same time. This whole stack is very fragile.
Pulse itself, the ALSA libraries on the external side at the user space level doesn't change that often. It's only when it's merging with the kernel module that you see the changes. So if you have ALSA kernel module 1.0.22 and also libs 1.0.22, you should be fine. Pulse audio is built against the external ABIs, not the ABI going between the kernel and the libraries. So it's the external stuff that really doesn't change that much. As a matter of fact, there was a couple releases where all they did was a bump sync with the module. So
yeah, just to keep the version the same.
Exactly.
Yeah.
So
I guess the two possibilities then are, the minimum will be to pull out
the minimum
codecs, right, and be able to apply quirks and keep the ALSA version the same.
Right.
Well,
right.
that's also
But and the real ambitious thing would be to pull the whole ALSA stack out.
The easiest thing would be to, actually easier-wise, would be easier just to grab whenever ALSA does a new release, grab their modules and their libraries and their utilities and rebuild them all and just do them as one big update.
The one issue, though, about having the ALSA modules separate from the kernel is there's actually modules in the kernel that require bits of ALSA, like DVB cards. I remember in UTS Mountain View last year, it was proposing how about we have the module separate from the kernel, and the kernel card says no. There's other parts of the kernel internally that need the ALSA code.
Yeah, so right now in Audi it's a giant...
But those are usually linked against the ALSA core modules, not the ALSA hardware modules.
Yes, this is true.
And the core modules don't change that often either.
But then some DVB card, I've heard of DVB cards, for example, having audio inputs and outputs that use ALSA. So
yeah, but those are actually part of the ALSA drivers.
Right.
So when you change the ALSA drivers, you're bumping those up as well. You don't worry about it.
Right.
So yeah, I know what you're talking about, but yeah, when the ALSA driver changes, the ALSA driver package changes, you're also fixing the DVI or the recorder stuff as well. So honestly, I don't see any major problem as long as Pulse Audio is using the ALSA lib ABI and not trying to drive into the hardware level.
No, it doesn't. But what it does do is it uses the hardware access part of the ALSA API.
Right. Well, so as long as it's going through the ALSA lib API, there shouldn't be a problem with bumping the ALSA libs and the ALSA modules at the same time. That's actually what ALSA is designed for. It's designed to be separate. And to really make it easy, we could somehow get it wedged in with DKMS, so that whenever we do a kernel
ouch.
well,
that many drivers building that with DKMS. Daniel and I were talking about this, and we just said
you
no.
only have to do that once when you do a kernel update.
So it's.
But imagine right now if you did anything. Imagine right now if you did a kernel update on any platform that uses an external video driver.
Is that
You still
considered
gotta-
too fragile for a critical subsystem?
So actually try to use DKMS to build some DKMS drivers against Hardy, which does have the Ubuntu modules versus core kernel split, and it's impossible.
Pardon my ignorance of the finer points of this, but it seems one of the things I guess I heard is that we could get a lot of benefit from having the quirks more basically being able to change what we currently change to a quirk in the kernel being more easier to do or less invasive to do. Is that a fair statement? So I'm wondering, is there a mechanism we can use where we can basically move that quirk, the data that we currently store as a quirk in the kernel, into user space as suggested, or have it in some mechanism where we can get it both from user space and the kernel? Now, one way we can actually do that is actually what Luke touched on earlier on, is through the device tree mechanism. Because if we were to put that information into a device tree format, the kernel already knows how to deal with the device tree. There's code in the kernel for device tree handling, and there is user space library code available that knows how to talk to device trees as well. Now, this would mean we'd make a change, have to make a change to kernel and to libelster and a bunch of other places on a one-off basis. Then all we're doing is changing device trees from there on in because it's being picked up through this.
I think the idea with the device tree, if you get it right in the device tree, you don't need a quirk at all.
Right. Yeah, that's right. It's replacing what we currently store as a quirk by putting it in a common place. Now that means some one-off sort of invasive development, but once it's done, it's done. And then I think this
But we're forked from also.
No, I propose we do it in such a way that the ALSA guys would be happy with it, hopefully, and then it could become the standard way of
I think long term.
Right now, they would actually go for something like that because 80% of the maintenance for just HD audio
Is adding quirks.
is
Quirks,
adding
yeah,
quirks,
yeah.
adding platforms.
So I guess that implies a question for us. That would mean we're doing some one-off development, but I think that would be a fair amount. Sorry?
Editing a text file.
Yeah, it's a text file, but the changes to the kernel and libelster that support it would be something we'd need to get done. But then
in principle, I think this is a great idea.
And the from a user perspective, it's a win.
Nicely. What I'd like to see is a plan which treats that which has a holistic view of it, right?
Yeah.
So a plan that just says, "Wow, we can make ALSA better like this," doesn't help us as much as a plan that says one Ubuntu user can help another Ubuntu user and connecting, and all the pieces that need to be connected in that. It's ultimately it boils down to, as I understand it, the sort of inputs to this are kernel modules, quirks, ALSA configuration, and pulse configuration.
To a less extent, Pulse, but Pulse.
Right,
Yeah.
and so we need to have a view which says, we can get this right, give me the ability so some Ubuntu user can have a button where they say, get my audio right. And
I guess that's the thing, because as Tobin can vouch for, actually finding out the pinouts for a chip is not exactly easy sometimes.
Right, but only one person has to do it. If we do our job right, then only one person has to do it.
So even there, if we could get a user space app, and actually also does have somewhat of a low-level user space app for doing this stuff through also Mixer, but having a user space app that exposes the entire codec, that a user can just start going and clicking buttons and turning knobs until something works, then they can go, hey, save. You know?
I've done something similar for Hotkey, which is a similar issue. So like each new laptop model has new scan codes for those, and I wrote some tools which basically show you the scan code for a particular key, and then provide the user a recipe how to map those to the key names that we are interested in, and then say, please submit this and this and this information, and which we can then turn into the proper commit. And it seems to me that this should be similar for all some mixes, so you could just like output a beep to an output and say, so which kind of output it came out of, and so on.
The only thing
so if you have a mixed combination of like a recipe and some tools which make it easy, then you get lots of output.
The only thing we can't
like in the dozens.
The only thing we can't guarantee with users doing that is they might, like, their hardware may be capable of digital HDMI out. We can't guarantee that they can test that. So they may only be able to test the analog ports.
It only takes one person. It's a crowdsourcing process. Right?
Yeah.
It starts out, they send it incomplete thing, somebody else approves it.
Yeah.
Right, so they may have just a laptop and they get the basic audio working, and somebody
Yeah.
else hooks it up to the SP-Diff port,
Yeah.
gets that portion working.
Exactly.
You
And the
know?
other bunch is about maintenance. It sounds pretty crazy to always bump to the latest ALSA version for the stable release because it's very regression prone. So if you just bump this kind of data, then it's very...
I'd be far happier with doing updates of quotes tables than updates of
Yeah,
also.
and I think if we had that unit that's done in device tree like I merely propose it because it's a well understood mechanism for this metadata
That seems reasonable, yeah.
kernel already. If we do it there, then we update the device tree table package or whatever it ends up being called. We don't touch kernel, we don't touch ALSA proper, we don't touch a bunch of stuff. It's just
Well, see, one thing that's actually been doing that's happening in ALSA utils upstream is they're actually starting to build a database of volume settings for sound cards.
Yeah.
I think that if that database also supported the quirks for the hardware,
Yeah.
we have it all in the one big database. Then it's just a matter of updating the quirk table in ALSA utils, and that's it.
What is actually the input to that lookup table? Is it like the vendor model strings for the laptop, or does the sound chips have some identification?
It's interesting because sometimes the PCI information only is not enough. You need the subsystem ID.
Right. So the PCI information gives you just the ALSA bus itself for HD audio. That'll just give you the bus ID on the sound system, and also some external cards use the same HD audio interface.
I mean, vendor product in the sense of DMI, so for the entire system.
Well, yeah. Once you get the bus ID, you can use the subsystem ID to identify the specific machine most of the time. Macintoshes, for some reason, don't do that, but other systems do. And then once you have that, then you can go down and actually probe the bus for the different codecs that are on there. And codec-wise, the specification for HD audio can support up to 16 different streams or codecs. Most platforms, most chipsets are hardwired for 4. Some chipsets are hardwired for 2. Netbook systems and notebook systems generally will have 2 codecs on there, one for the audio, one for the modem.
No, my question was actually, how do you select the right set of quirks from your large table?
The way ALSA works, the first thing it does is it looks for, is it an HD audio or is it AC97 or whatever, and it goes to the proper driver. And so an HD audio driver loads up, it looks at the codec that's on there and the codec model number, and then it goes to that core of the driver. So it says go to Sigmatel, go to Realtek, go to Analog Devices, whatever. It loads that module, sub-module up, and then it goes through and says, okay, we got this model of this Sigmatel chip, and then within that model it has a complete list of PCI subsystem IDs for the different platforms.
But it seems that
That's the quirks.
That's the quirk table.
Yes.
Well, it seems a lot of that data is already available in the Sisyphus tree, but it might be that some of those aren't. So I guess
Last time
there
I
might be
looked-
some extra information you have to put into this so that we can measure it in UNIF rules or whatever.
Last time I looked at the tables was in version 16 of ALSA. It was the last time I actually did heavy-duty development in ALSA. And at that time, there were 5 different codecs that were supported. There were 92 different chips within the codec manufacturers, and then there was like 600 different platforms within the quirk tables. So, and that was back in ALSA 16.
That's only increased since then.
Some of the drivers don't completely use the quirk tables, though. Some of them do detection and the quirk tables.
Right.
So that's part of the issue. Some of the drivers actually go in, they'll detect, and then they'll say, oh, you're on a ThinkPad, so I'm going to go ahead and make this, mixer this as opposed to this. So that's
just because they haven't been added to the quirk table yet.
Well, no, the quirk's in there, but the other thing that the driver is doing is also detecting as well. So the quirk, some of the drivers only have like very small quirks, to certain codecs, because they know that this revision of the codec is in a certain laptop, and we need to go ahead and just add a speed of out, or add speed of out to this output for this.
Well, yeah, but that's how the quirk table works.
Okay.
I mean, the quirk table basically says, okay, this platform used this model as a reference for design, and then it goes through and actually programs the different pinouts, controls whether or not you have headphone detection and microphone detection, things like that. So, and again, that can be different on every single motherboard.
I think the device tree model is, I guess, it's somehow easier to have to be generated.
Well, the device trees conceptually can already cope with a combination of probe and pre-detectable, predefined hardware. So
right. So I don't know how device tree works, but ideally it should be able to look at the subsystem ID and just look up a table from there, and it just should have a series of registry entries that program the pins that it needs.
I mean, all the device tree isn't a cure for every cancer, but it's just giving us a common way of storing this sort of metadata and being able to deal with the concept that the device tree library lets you do things like add nodes to the tree at runtime. So that would sort of help in the situation Jerome's describing, where you want to auto-detect something, you have a combination of predefined and auto-detected hardware in the system.
So how's this going to help us for Lucid, though?
Yeah,
because we're talking about futures that really
I think
going to
I was going to
involve...
get Jeremy to do it this afternoon.
I want to sell
No, he told me to do something. I'm going to really go back to the two earlier ideas, which is, can we have the codec modules separate from the kernel? Gives us one level and ability to do quirks outside of the kernel we picks.
Maybe we can start small and put some of the data, make some of the changes we need.
It would take a little bit of effort, not a whole lot of effort, but it would take a little bit of effort to take the ALSA upstream patches that are adding quirks and backport them to the ALSA version that we're running.
That's right.
So that's a minimal approach.
Right. That would probably be the quickest, easiest thing, and then just update ALSA base.
But if we did that to the kernel, right, at some point we run into kernel freeze and then we stop getting enablement stuff, right? So...
Well, it'd be interesting to dig. We may need to dig in this more than we can in the time in this session, but with the time involved to do those backports versus move a representative amount of stuff across to using the device tree, that might be a bit ambitious. It'd be interesting to poke at.
But the volume database that you mentioned, is that going to, putting some effort into getting that right and possibly extending to certain extra functionality?
I think Daniel was hinting at trying to start getting that sort of stuff happening for Lucid. I need to talk to him more about that, because generally in that situation, I think what it will be a matter of doing is just getting users to set their volume and submit it, and we just process all the data and send it upstream and put it in the package.
Exactly.
So I guess we can pull out that database and create a device tree.
Well, you don't necessarily have to convert all of the existing stuff. You just have to add a new interface for CFS, so that if the kernel already has the quirk, it can use it, but you can additionally apply quirks from outside. Cool. So, do you think this would even be a feasible goal for Lucid? Or?
I don't think so.
No, there's a lot of big structs in the HDA code that just line after line after line after line after line.
If you were looking at moving the data structure that's in HD audio right now and moving it into user space, you'd really want to fork HD audio to start with. Start with a core HD audio that does the generic setup, and then start plugging into that at the user space level.
Yeah, actually, my question was not to whether we can move the entire database in the Lucid timeframe. I don't think we would have to provide an additional interface to poke new quirks into the kernel, like through the SysFS tree or.
I think there is the ability to do something like that.
There is a tool. There is a user space tool for HD audio that allows you to a command line tool that allows you to program different verbs into the audio codec, but that's going to be really kind of difficult to. You could probably do something. You could probably do something within Lucid time frame.
It's been a while, but
I still think we're better off looking at either backporting quirks to the particular codec modules, or looking at the wholesale ability of having later versions, the whole ALSA stack.
Now the other thing is we're not
pushed for these updates. I think it sounds way too regression prone. I think.
Yeah.
The other thing is with the quirk tables, if we don't
for the quirks, backporting the quirks.
No, the backporting the quirks is fine, but not updating to a whole new version.
So what about backporting to a stable ALSA branch? Have that separated, like we have the ALSA module snapshots now. for karmic. Instead of that being a snapshot, say, okay, we have a stable branch of ALSA, we'll backport things potentially to that stable branch package, and that's, kind of, I don't know, kind of a midpoint. I don't know. How do you guys feel about that?
Well, one thing that'd be easier than just doing the quirks, if it's just a matter of adding a PCI subsystem ID, instead of doing that, we could have a user space application that will detect and see if that's getting automatically set by ALSA. And if the quirk table isn't getting set by ALSA in the module level, if you're just adding a PCI ID, just having the system point to a different model in the table, we can actually have a user space thing that will change the MALSA or the modules.conf file to say add model equals
stuff, yeah.
Yeah, that'd be the easiest thing to do.
That's just for PCI ID.
Well, yeah, but that's PCI subsystem ID.
Yeah, but what if it's the quirk of microphone or whatnot? Then we
if you're adding a system to an existing model within the driver, this is the easiest way to do it. All you're doing is adding a model equals. You're either adding a model equals in the driver, or you're adding it at the module line, the module load line, which modules.conf will handle.
Yeah.
But for some codecs, it's a little bit more.
That's when you're adding a new codec.
Well, not necessarily adding a new codec.
Or a new wiring of an existing codec. Which doesn't happen nearly as often.
Oh, so most of them is just adding new systems to the same set of configuration?
For the most part.
Oh, okay.
There are a few times when they'll use I've seen some systems that, like the Q1 Ultra, for example, they're using a 7.1 surround sound codec for stereo audio output. It's actually ridiculous. But it was what they had available. So they're actually I think it was the microphone that's built into the Q1 Ultra is going through the center/LFE channel in the chip itself. So what on a desktop would be the center/LFE output, they're using that as the microphone input jack. So
Martin, what's your objection to grabbing the whole stack?
Well, basically, as usual, whenever we upgrade to the new version, then we're very prone to break something that worked before. And enabling a new platform is not nearly as important as keeping existing platforms running.
Now we have, maybe we have the libraries and the modules in sync. We now have the modules out of sync with the kernel. That is just
the modules,
pushing the sync problem down one variant.
The modules, when ALSA does a module release, they're always releasing at Linus's tib kernel version, and then it's backwards compatible from there. But when we pull a kernel version, by the time we actually do a release, we're 6 months behind what ALSA's already snapshotted into the latest kernel.
Sure, but all we're doing is moving the version. All we're doing is moving the version from between the library and the
But that's why ALSA changes that often, is because 90% of the changes are hardware support.
If the majority of the hardware support works, we can do that backport without a whole lot of effort. But once the
if we had to do the individual quirks, right? It's a lot of effort versus grabbing the whole stack. So it's a trade-off there, and it may not be possible to grab the whole stack because there could be something required that's not in our kernel.
That's what I actually thought. It would be so much simpler to extract the quirks table and have that as a text format somewhere, which you could then backport and even keep it sync between the different releases.
Actually, what I don't think we want is for an LTS to backport the whole stack and then potentially fixing or getting more enablement, but potentially get a lot of regressions by having new bugs in that stack.
By using a kernel that didn't actually ever exist.
And even with Hardy, we had the problem, you not only have the kernel modules part and you need the headers, because some people compile extension modules which requires the old ALSA headers, and then you have two locations of headers potentially.
But we're stuck in a situation where we release with all ALSA. every time.
I mean, if we could feasibly get to a point where we can add new quirks by some mechanism, I think that...
Well, I think, like I said, the easiest thing to do is, if we're not adding codec support, we're just adding quirk support, we can do that at the user space level by having a UDEF utility that detects to see if the kernel module is aligning itself with a known quirk that's in the module, and if not, see if we have new additions to the quirk table that we can just add a module or a model equals in the module.conf config file.
Yeah. No, it's actually similar to what I was proposing. So not converting the existing tables, but adding new mechanisms.
I mean, that kind of thing we could do fairly easily within the Lucid time
It
frame.
seems to be so much easier to do that work up front and then save all that work during the support period.
And that's assuming that hardware vendors don't get crazy with their codecs and start doing really weird wiring schemes like they did with the Samsung Q1.
Right. I mean, right now we cannot easily backport support for any of new hardware, and then if you can at least cover half of the new hardware, then it's already a big improvement.
The areas you're going to miss are basically the ones where they're doing odd wiring schemes and new codecs, which new codecs don't come out.
Functions.
Well,
occasionally, stuff rolls out that you can't just grab the quirk and backport it because.
Well, yeah, that's because of the wiring that they do. Yeah. They wire this port to this channel as opposed to the way the codec design spec says this should go to this module, kind of thing. That's just like I said, that's just a wiring thing, and it takes a little bit more than just updating the quirk table for that. That's where we may have to get into something like using HDA verb, if we wanted to do that, if we wanted to support that. But at that point, the only thing we'd lose is supporting new codecs themselves, which is not that big of a deal because
even the eventual drop device tree won't necessarily solve that because that's actually requiring new code in the driver.
Right. Yeah. The quirks themselves or the codecs themselves, hardware codecs only come out. I think it's about every 12 to 18 months, so you're not losing a whole lot there. So.
At least every 6 months there seems to be some new ones.
It depends on, well, I mean, if you look at it on a vendor-by-vendor basis, like Sigmatel, IDT only releases like every 12 to 18 months. Realtek, they're just not in sync.
Yeah, but even then, I mean, you feel like...
Need Mark to talk to him.
Like, if we could certainly talk about updating, like backporting a new codec like 1.5 years after Lucid was released, because then you would do that once or twice in Lucid's lifetime. But if you don't really want to do this process like every 2 months when you release a new kernel for Lucid.
And the only real reason we'd have to do something like that is supporting OEMs that are pushing out new netbooks with newer codecs. And they're usually, I don't know how, what they're using anyways, but most users are going to be loading the latest.
I was just going to say, wouldn't your netbooks be loading the latest Ubuntu at the time anyway?
For the most part. I mean, they may ship with, like you may buy a Dell right now that has Hardy on it, but the user's going to take that and go, I want to install Karmic, because Karmic is so much cooler. So.
Well, that's for the consumer user, but for your business user, they're going to want to have LTS as their preferred.
Yeah, even there though, they're going to want to have hardware support. Most of your long-term support is going to be done on the desktop and server side. Netbooks are going to be spinning too rapidly to do any long-term support like that.
Well, I guess the thing is so you have a bunch of corporate users out there. They have a certain netbook. Those netbooks get phased end of life. New netbook comes in, has a new codec or a new quirk, and how does Lucid, stand the test of time to be able to support that? That's
well, it's only 3 years we need to think about it for the desktop.
Well, that's on desktop.
Only 3 years. Well, there was some talk, though. I don't know. Pete mentioned the idea of supporting newer kernels on the LTS. Now,
that would help.
At the last UDS, we talked about this, and desktop was put off the table because Tim said he didn't want to deal with ALSA and some of the other, the wireless stack and some of those problems.
Well, the other thing you're going to look at also is the video stack.
Yeah, so I don't know if the same.
There's several stacks.
If we're just going to be looking at that for server,
right?
kernels for LTS or not.
So this morning you just said server, you said
Yeah, and
if you're
also-
on desktop, you have a
Like supporting doesn't mean we would upgrade existing users. So I thought it was more like spec ports, more
Yeah, you
this
can
kind of approach.
optionally add on new kernel. And I think the target is still
More server.
oriented.
Yeah.
Yeah, and also I mean you could ask Dell if they should like use it a year after it's released to install the backport to 6.33 kernel on their new models, but you don't necessarily want existing users to upgrade to that automatically.
Yeah, but then if people discover it and use it, if it's a whole kernel and then it's out of sync with ELSA, it can, yeah. But
Maybe we need to consider having desktop kernels for this purpose, for audio enablement, for LTS,
Yeah.
separate from server.
Well, when you get into the
LTS is fault.
What's that?
Isn't that what non-LTS is for?
Yeah. I mean, realistically speaking, when you get into the desktop and netbook mode, when you spin a new kernel, you're also spinning new X video drivers.
yeah.
So,
Well, not XVIDIA.
well, Intel's X video driver is tied to the kernel driver, isn't it?
Yes.
Right, so they split
Same
that out.
with
So
NVIDIA.
that split out.
I guess the same
Also,
situation they face is the same situation.
One at a time, guys.
All right. So what do we think? We're almost out of time. What do we think we can get done for Lucid to try and make things just a little bit easier? So I guess what you're saying, Tobin, about the try and work out whether there's a model equals command line option for the module.
Right.
How easy would that be to reliably find that, yes, this machine will work with that model argument?
Well, that's more of that's something we'd have to push out on an update thing when ALSA pushes out a patch within the ALSA driver tree.
Yep.
And just adds a new quirk.
Yep.
Then we can update our text file database, for example, whatever it is.
Yep.
To just update that.
Right, so you're saying we literally examine the output of LSPCI and sort of make the call on that?
Yeah, pretty much.
Right, okay.
So,
Well, we're basically writing new code that's going to be doing this, and then
well, like I said, you're looking at I don't know the specifics of it, but you're looking at like a UDEV module that gets loaded up at boot time, that when the HD audio module loads up,
right.
it'll have something in /sys, sys modules HD audio, that'll tell you what model it's aligned to. And if it doesn't have a model equals in there, then it's not aligning, you can't find anything in its own lookup tables.
Okay.
And that's based on the subsystem ID. So if we have a UDEV file or a UDEV script that says, hey, the module didn't find anything in its own tables, let's look at our external table and see if we could find anything.
Or rather, just
So we're
always
talking-
look at them because you might want to fix previous tables for your system. So they
Right.
can overwrite.
So,
I mean, so UDEV is pretty good at looking up large tables of like vendor product IDs. It's pretty fast. So if you have one in your user space, there's no reason to not use it.
right, but the user space table wouldn't even need to be as big as the module table.
Right, it would very much be
Right,
like
it's
a
an
Delta.
exception table.
Exactly.
You don't find it, okay.
It's
You have an
exactly. It's
exception.
just like it's like a CPU patch, or a.
My only concern with doing this is that I think it takes a little bit of focus away from getting all the other pieces working as well as they can at Lucid. I think I don't know how many people saw Leonard's little rant about Ubuntu and the state of Pulse Audio.
I think in terms of that, we basically. I think it's the whole process is twofold. We try and get as many quirks into the kernel within reason before we start freezing up for Lucid. At the same time, we get the infrastructure for this exception table in place, and these exception tables are then only used for post Lucid.
But I guess, let me just finish that thought, because I guess what I'm saying is that a big feature that we really tried to get into Karmic that didn't land is the real time, the RTK stuff.
Yeah.
Okay. And there are some other pieces that don't work in Karmic, like monitoring of input.
Right.
And so
Well, that's a UI and Pulse thing, yeah.
if we were to spend effort, on this new thing, does that take away from us making sure that Lucid has the best Pulse Audio stack so that we can say, look, this is.
Okay, so we got two problems twofold here. You've got one at the hardware level, which we already discussed.
Right.
The other problem that I've seen with Karmic, and I saw it mostly on the ARM processors that I was working with, is the audio controls that are in the desktop, the Ubuntu Karmic desktop, don't touch the hardware at all. It only controls the audio feed, the audio stream. So,
right, by design,
with the Marvell platform, we were testing it out, and none of the guys on the team could get audio to work on their Marvell platforms. I went in with ALSA Mixer and said, "Oh, wait a minute, we're all muted,"
Right.
Even though the ALSA,
you guys need to work closer with myself and Daniel to try and make sure your needs are met. We haven't heard from you, so far as I knew, I thought, oh, everything's fine with that, because I'm interested in making sure everything's okay for you guys, and I haven't heard from you. So.
Well, there's a bug filed on that.
Yeah, so Pulse Audio actually does the screw around ALSA, and that's I think what Luke was alluding to.
Do we have other sessions for audio scheduled this week?
Not that I know of.
Okay, so we should make sure that, because there are definitely some topics like, especially the whole RT kit thing.
Well, that's going to be okay for Lucid, because the kernel patches are there. RT kit's going to happen.
Yep.
So we should have a spec for post kernel release quirk updates of some sort, and then another one for Pulse Audio controls.
Right. Well, back to your question, it seems to me that people working on these kernel bits are not necessarily the same people that are working on Pulse Audio. So I don't think that working on one area blocks the other.
Well, I know for one thing, I personally tend to focus more on user space than I do kernel space.
And I think that's been a problem. That not specifically you just working in user space. Yeah. I think we really need to look at audio as the complete stack, and we haven't done that.
Right. I just meant because you were concerned about taking work away from Pulse Audio in favor of working on the kernel, but since it's probably not the same people, this is probably not an either-or decision. It's more like a decision. Is there anyone who could or would like to work on the kernel?
So how about the checkbox style, testing to make sure the stack works, and then any one of us, kernel, user space, whatever developers, can just run that and go, hey, does this thing work?
And there are dedicated audio kernel resources for Lucid and Lucid.
I know Pete promised, so this is very good.
So are the snapshots still going to be provided though in Lucid as they are in Karmic now?
Well, there's only one snapshot, but I don't think that LBM package for ALSA is going to be updated. I don't know.
I'm planning to do a build of Takashi's tree every day.
Okay, but that's in the one that's in Universe. So there's actually a Linux
LBM
backport. Yeah, there's a one specifically for ALSA, for the ALSA snapshot.
Yeah, LBM ALSA. Yeah.
Okay.
Yes.
Okay.
All right. Well, I think we definitely should schedule another session later in the week. Maybe a couple of us will get together and figure out what that is.
Yeah. Actually, part of the reason why I sometimes find it hard to test the Pulse Audio stuff is because I can't use it all the time anyway, because speech doesn't require it. That's something else I'll be working on this cycle. That's another story, but yeah.
Right.
Well, not so much that speech doesn't require it, doesn't play nice with it, so I hope to solve that.
I don't know if we made any decisions.
We need another session. Another decision.
Okay, that's all right.
Tobin, can you get me a bug number for that ARM issue?
Yeah, I'd have to look it up.
Okay.
Let me see.
Can you remember what it was filed against?
Well, Tony, it didn't really seem to me that anyone was arguing against making this.
It's filed against Marvell, but I'll look it up here in a minute.
Okay.
Look up tape. It's just that nobody committed to doing it.
Nobody's committed to doing it, but I still think that this is something that it was mentioned before that the ALSA team tried to do this before and they haven't, right?
Well, the biggest problem is just lack of people steady support. I mean, I worked on ALSA for a year while I was unemployed, but then I got employed and I didn't have time to work on it anymore. So
Well, it seems like if someone would provide like a new mechanism to poke those new quirks into the table, kernel, it would certainly affect.
Well, it's not that difficult to add PCI quirks to the table, but when you get into some of the other extreme ends of it, where you're adding a whole new codec or things like that. I mean, when I was doing also support, I actually had Realtek and Sigmatel and Analog Devices sending me test boards, so I was actually doing the hardware level development.
Right, but I mean, it seems to me that like adding a completely new codec versus like adding a new for enabling a new PCI product that are two different problems.
They are.
There are.
Yeah, so there's some that are like one-liners.
Right.
It's easy. It's when you have to actually figure out what the hardware is doing and define it.
Well, it seems to me that nowadays you don't even have the mechanism to do the very easy thing for user space.
Well, there's two different levels to it. You got the new codecs, which are the hardest part to add. And then you've got the vendors that are taking existing codecs and wiring them up in really odd, strange ways. And you're trying to figure out, okay, the internal mic is going through the sound and bass outputs.
But sometimes they even have support from the vendor. I mean,
sometimes, very rarely.
Worked on a netbook last year. I was working directly with IDT, Sigmatel, and they were they're saying, oh, well, you're going to need also 1019. And I'm like, guys, we're on 1016. What? And then they would have to backport big chunks of ALSA to support this particular new variation.
Right.
And I mean, with Karmic, with my other MacBook, I plugged my headphone jack in, and I still got speakers blaring, and everybody in the office is hearing.
Well, that's mainly that's partially a problem with the MacBooks in that there's nothing in a Mac that differentiates between the different Macs. So you can't do a PCI subtable lookup. You have to do some really, really strange.
Yeah, you would certainly have DMI data to get the model and so on.
They have to do some really strange lookup stuff to figure it out. They can't use the PCI table.
But this is an example of it's going to get fixed in the later version of ALSA that's not in Karmic. So I'm like stuck with like a brand new release, and I'm like,
to get the auto sensing to work. So there's a few machines out there where you have to use the snapshot release I was talking about to even get the auto sensing or even get microphone input to work.
Right. So see, one of the things that they've done with the later versions of ALSA, and I believe it's coming out with it's not in Karmic, but it'll be in the next kernel, is they actually have the sense detect, the headphone detect.
Sense, yeah.
So that it's actually coming out of the kernel into user space. It hasn't before. It's always been within the kernel module.
Okay.
So now that they're
device nowadays?
What?
Isn't it the input event device nowadays?
It's coming out
quite a while already.
I believe it can. It started maybe with 20, but it doesn't have all the codecs in there.
I thought I tried it like less than a year ago, and I already got some input events when I was plugging in.
But again, it's just a matter of what codecs within the module support it. I mean, all the codecs will support it. But it's a matter of who's gone in and actually upgraded the codec support. Because like my desktop doesn't support it, but my desktop motherboard is like 3 years old. So.
All right.
So we're
wrapped up. I'll take the action on scheduling another session.
I'll write up a spec for the audio, the hardware level stuff this afternoon and get that to you.
Okay.
So we'll get that in schedule.
Maybe
you want to do another one specifically?
Just specifically for adding quirks post kernel release.
Oh, yeah. Plug your loop.
So you might
Yeah, sure.
Figure out an architecture for doing a UDEV type script type thing.
They're free.
Cheers. So I guess what we need with the whole we need people regularly testing the different platforms we have with Pulse Audio. Like we need people testing with ARM and like the thing this is the thing. Most of the devs who work with the also in Pulse, we tend to use HDA. So HDA has become pretty much the reference platform.
It is
for Intel.
Well, for x86 hardware, which is 90% of the business.
Yeah.
ARM stuff, we're kind of blessed in that if we have an SoC, it has one codec built into it. You don't have to worry about it. So right now we're supporting 2 different SoCs, so we got 2 different audio things to support. So it's a done deal. But with the just for netbooks alone, we probably have about 150 different subsystem IDs we got to plug in on a monthly basis.
So, are you thinking about a separate section
I think we need to do a follow-up session on this and really,
Yeah.
because I mean, we could write up a spec, but do we have?
Well, spec's going to be with
just
some people
build?
follow post UDS,
And I'm not sure. Yeah.
but it's another matter of do we have head count to actually do something some work on this?
You never know.
And also, do you actually think we need another session to discuss the details of this, like kernel user space lookup tables thing, or is it just something that you should written down?
Well, we should have a spec for it at least, so that there's something in a wiki that somebody can say and jump
Yes, we
on and
wanna
say,
do
yeah, I
this.
can do
Yeah,
this.
we
and
wanna
run with
do
it.
this.
Whether we need it as a session or not.
Totally makes sense to have a wiki page for it, sure, but I mean, before another session, it seems that everyone's pretty much agreed that it's a good idea to do it.
Martin, we do need. I think we need another session to talk about audio specifically across the board, top to bottom.
Totally.
What we do for this release to make it rock.
Right.
Because, as I said, I mean, I don't know. Leonard really kind of put a shot.
I like the
across
non-hardware
the board.
enablement.
Yeah, and how? Well.
The thing is, we also need to probably do good test. Like Lennart says, to get good pulse audio stuff happening, you need these things in the kernel. We actually need to test to see how much of a difference they make.
Absolutely. A bunch of us were at Plumbers, and we tried talking to him about some of that, and we get a very good response from him. But I think there are some things that we can do to try and make sure that Lucid lines up and is better than Fedora 12 with regards to kernel settings and audio. So I think that's what we want to talk about the next session. Is like, how do we get some of this information?
Right.
This is going to be that most netbooks are like only 32 bits because the whole timers thing, the config hertz setting, according to Lennart, makes a big difference. Like he reckons we have to have 1,000.
I know, but the kernel community is going the other way with that. There was a session at Plumbers